Hi everyone, it's Matt with AUB. For the final touches of the preparation of IBA direct test, I have selected some sort of one-liners, one-liners, and they are good ones. They are qualified for the criteria of quantitative mathematics. Our question number one reads as write the following numbers in scientific notation. Scientific notation. Scientific notation. Scientific notation reads as decimal must be placed after first zero non-digit. Maybe 1 point something, might be 2 point something, might be 3 point something, and so on. Decimal must be placed after first non-zero digit. Emphasis on first non-zero digit. First non-zero digit is the place where decimal is to be placed. First non-zero digit. First non-zero digit. Let's see. Question number one is 68.75. 68.75. 68.75. Here the first digit is non-zero. We have to drag this decimal from in front of 8 to in front of 6. It will become 6.875. Then introduce 10 raised to how many digits? The decimal has traveled one digit from right to left, one digit from right to left, one digit from right to left. The exponent must be raised to positive one, owing to the single digit travel. Owing to the single digit travel, power must be power positive one, positive from right to left, right to left. So our answer is 6.875 times 10 raised to 1 or 10. That's the scientific notation of this one. Let's see question number two. Good one. Giving concept, making the concept more clear. 53, 5373.458. Now we have to shift this decimal to in front of 5, in front of 5, in front of 5. It will become 5.37345. How many digits the decimal has traveled from right to left? 3. 1, 2, 3. 10 raised must be to positive 3. 10 raised to positive 3 is the scientific notation of this thing. We have to place the decimal after first non-zero digit. After first non-zero digit, we have to place decimal. After first non-zero digit, we have to place decimal. If the decimal travels from right to left, right to left, right to left, then the power of 10 must be positive, must be positive. If that is the direction, from left to right, power must be negative. Power must be negative. Upcoming questions clarify the concept. Question number 3. Question number 3 reads as change me the pass me some marker. That is 756,837. There is full stop. Full stop to be converted to decimal. This decimal travels here after 7 point. After 7 point. After 7, we have to place this decimal. 7.56837. How many digits? How many digits the decimal has traveled? 1, 2, 3, 4, 5. 5 digits. Means we have raised 10 raised positive 5. 10 raised positive 5 from right to left. From right to left. If the journey of the decimal point from right to left, we have introduced positive power. Positive power. So our answer is 7.5683. 7 raised 10 raised power 5. 10 raised power 5. This is known as scientific notation. Mostly it is used in celestial object calculations. Their distances are in light years, so it is very convenient to write such type of form. If there is 3 with 300 zeros, then it's enough to write 3 raised 10 power 300. It's enough. They are calculated. They are used mostly in terrestrial minutely, but in celestial bodies, heavenly bodies, when we are dealing our astronomical concepts, then we have to use this one to find the mass of Jupiter, their diameter, calculation involving these planets, Jupiter, Mars, Neptune, Uranus, and whatever the case is. Celestial object. Such type of calculation, such type of scientific notation is very convenient to deal with. Okay. The final question, still there is one remaining. 0.053. Now our decimal travels from left to right. From left to right. How many digits? 1, 2. 1, 2. It will be 0.05.3 into 10 raised negative 2. 10 raised negative 2. When the decimal travels from left to right, exponent of 10 is negative. Exponent of 10 is negative. If it travels from right to left, the exponent of 10 is positive. The exponent of 10 is positive. So we have done with our question number 1. Moving towards question number 7. Question number 2 is converse of this one. We have given scientific notation. We are asked to write its ordinary notation or ordinary form. Scientific notation is given to us 10 power something, 10 power something, 10 power something, 10 power something. We have to write in ordinary type. Let's see and find out from scientific to ordinary now. Our first question is 2.576 into 10 raised 7 into 10 raised 7. 2.576 10 raised 7. 10 raised, we have to write in ordinary form. 10 power 7 means 10 with 7 zeros, 1 with 7 zeros, 1 with 7 zeros, 1 with 7 zeros. It will become 2.576 times 2 0, another 2, final 7. 1 with 7 zeros, 1 with 7 zeros. If we multiply our decimal travels 7 digits in that direction. Our point travels, decimal travels 7 digits in that direction. 7. 3 are there. 4 we have to manage. 2, 5, 7, 6. Oh, how many digits? 3. 3 and 4, 7. This is the ordinary form of this scientific notation. 10 raised 7. I have written 1 with 7 zeros. Now our decimal is going to shift from left to right, by 7 digits. 3 are there. We have managed 4 in the form of 0. So that is our ordinary number for this scientific notation. Another C and find out what happens if the exponent is negative. What happens if the exponent is negative? What happens if exponent is negative? Let's see and find out. We have 0.0056 into 10 raised minus 8. Look at this. Power of 10 is negative. So decimal has to travel in that direction. Exponent of 10 raised minus 8. Exponent of 10 is negative. Decimal has to travel from right to left. How many digits? 8 digits. We have to manage 8 zeros. It will become 2 zeros, 2, 2, 4, 6, 7 and 8. Point must be there. And these calculation remains same. How many? 0.056. 0.056. That is our ordinary calculation for this one. 10 raised negative 8. Decimal has to shift 8 places, 8 digits from right to left. I have managed 8 zeros. 2, 4, 6, 8, and this one as given to me. I have intact. That's our ordinary notation for this number that has been written in the scientific form. Okay, next is 1.3 raised 10 minus 9. 1.3 into 10 raised negative 9. Let me erase this first. 1.3 into 10 raised negative 9. So decimal is going to shift in that direction, 9 digits, 9. 1 is there, 1 is there, 1 is there. We have to manage 8 zeros. Let me write in simple form 1.3 times divided by 1 raised 10 raised minus 9. 1 digit is there, 2 zeros, 4, 6, 2, 4, 6, 7, 8, and 1 is already there. 1, 3, that is 0.00, another 20, another 20, another 20. How many digits? Calculate 1, 2, 3, 4, 5, 6, 7, 8, 9. 1 is there. 8 we have managed in the form of 0. 8 digits we have managed in the form of 0. So our answer is 0.0040 zeros. 2 more, 1 and 13 also there. That is the ordinary notation for 1.3 times 10 raised minus 9. 1.3 into 10 raised minus 9. That is the way. That is the way. If power is negative, then decimal has to travel from right to left. Right to left. As many digits as the negative power. As many digits as the negative power. And final is 1 into 10 raised 13. Power is exponent. Exponent is positive. Then point or decimal has to travel from left to right. Left to right. How many zeros? 13 zeros must be there. 1, 2, 4, 6, 8, 10, 12. That's 30. This is our final one with 13 zero. 1 with 13 zero. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's our answer in that case. That's our in that case. There are both forms we have discussed from ordinary to scientific, scientific to ordinary, ordinary to scientific, scientific to ordinary. Scientific means after first decimal, after first non-zero digit, decimal must be placed. After first non-zero digit, decimal must be placed. While in ordinary, we have to get rid of this 10 raised to any power negative. If power is negative, then decimal has to travel from right to left. If power is positive, then decimal has to travel from right to left. When we have to get rid of 10 raised something. Next question, another good question. The measure of diameter of the moon is 3,500 kilometers. The measure of the diameter of the moon is 3,500 kilometers. After converting it into centimeters, write it in scientific notation. We have to let me read this first. 3,500 kilometers, that's the diameter of the moon. 3,500 kilometers, that's the diameter of the moon. Diameter of moon is diameter of moon 3,500 kilometers. Simply we have given 35 kilometers. After converting this one into centimeter, we have to write in scientific notation. We know that from kilometer to meter, multiply by 1000. 1000 or 10 power 3 from kilometer to meter. From kilometer to meter, because each kilometer contains 1000 meters. 1000 meters. Kilo stands for 1000. Kilo stands for 1000. And we know that 1 meter having 100 centimeter. 1 meter has 100 centimeter. 1 meter has 100 centimeter, means 1 with double zero. So there are how many zeros? Total 7 zeros are there. 7 zeros. 3, 5, 2, 4, 6 and 7. That is overall calculation in centimeter. We have converted 3,500 kilometers into centimeters by multiplying first 1000 from kilo to meter, from kilometer to meter, from kilometer to meter. That is the required quantity. We have to multiply with 1000. From meter to centimeter, multiply another 100. 2 zeros there, 5 these are, 2 and 5, 7 zeros are there. Now we have to write in scientific notation. Scientific notation means 2, 4, 6, 7. We have to place this decimal after first non-zero digit. It will become 3.5. How many digits decimal has traveled? 7 zeros and 1 5. It will become 7 and 1 8. 10 raised positive 8. 3.5 into 10 raised 8. 3.5 into 10 raised 8 is the calculation of 3500 kilometers after converting this one into centimeter, and then we have written in scientific notation. From kilometer to meter multiply by 1000, from meter to centimeter multiply another 100. So there are 35 with 7 zeros, 35 with 7 zeros. Then now we have to write after first non-zero digit, we have to place decimal here. Decimal has to travel 8 digits, 8 digits. That's why I have written 3.5 into 10 raised 8. 10 raised 8. The next is the temperature at the center of the sun is 1560. 1560 degrees centigrade. Uh, Write this one in scientific notation. The final question for scientific notation, it is the temperature near the sun is 15 along with 6 zeros. 6 zeros degrees Celsius. Degrees Celsius. That is the temperature of sun. Temperature of sun. We have tried in scientific notation. How many digits point has to travel? 6 and 5. 1, 2, 3, 4, 5, 6, 7. Means 1.5 into 10 raised 7 degrees Celsius. Degrees Celsius. That is the temperature of sun near the sun in scientific notation. In scientific notation, 1.5 into 10 raised 7. Temperature of the sun is given in ordinary notation 15 with 6 zeros. Now decimal has to shift from this. It has to travel 7 digits from right to left. From right to left, it will become 1.5 into 10 raised 7. 10 raised 7. That is our scientific notation for the temperature of the sun. Moving towards next, some properties of real numbers, but good one, but good one, elegant one. Yes, A and B, also B plus E. Look at this. For all AB belongs to G, their sum also belongs to G. For each element taking from AB any non-empty set, their addition also belong to the set, also belong to the same set. It is known as Closure property for addition. Closure property for addition. For addition. While for all AB belongs to G, taking all elements, any elements, all elements at random from G and multiply them. Their product also belongs to G. Their product also belongs to G. It is also known as closure property under multiplication. Closure property under multiplication. Closure property. Closure property. Sometimes it is also called binary operation. Sometimes it is also called binary operation. Binary because we are taking two elements and we are operating them according to given operation. In that case, addition, closure property of addition, and in that case, according to multiplication, closure property of multiplication. Modern sort of mathematics. It is known as closure property with respect to addition or for addition, closure property with respect to multiplication or under multiplication. These are two different ways to say same thing. Second is A plus B is equal to B plus A. This is known as commutative property for addition. Commutative property for addition. Commutative property for addition, not minute plus. A plus B is equal to B plus A. Commutative property for addition. Same if A cross A into B is equal to B into A. A into B is equal to B into A. This is known as commutative property with respect to multiplication. Commutative property with respect multiplication. A plus B is equal to B plus A. It is known as commutative property with respect to addition or for addition. A cross B, A dot B is equal to B dot A. Multiply A with B or B with A. It is known if they are equal. It is known as commutative property with respect to multiplication. Commutative property with respect to multiplication. The next upcoming to A plus B plus C is equal to A plus B plus C. This is known as associative property under addition. Associative property under addition. Associative property under addition. Under addition. Where lies the difference? In that case, we have to move from left to right. First operate B plus C, first add B plus C, whatever the result is, then add with A. In that case, start from right to left. Start from left to right, sorry. Right to left, it is left to right. First add A plus B, then add with C. It is known as associative property under addition, associative law for addition. What's about multiplication? A into B into C is equal to A times B times C. This property is known as associative property for multiplication. Associative property for multiplication. Associative property for multiplication. For multiplication. Same difference. Starting from right to left, first operate B plus C, then with A. First multiply B into C, then with A. It is according to multiplication. And this from left to right. First operate A into B, then whatever the result is, operate with C, multiply with C. Associative property. Associative law according to addition. Associative law according to multiplication. Clear property for addition. For all AB belongs to G, A plus B also belongs to G. Clear property under addition. If AB belongs to G, for all AB belongs to G, their product also belongs to G. Clear property with respect to multiplication. A plus B is equal to B plus A. It is known as commutative property under addition. A into B is equal to B into A. This is known as commutative property with respect to multiplication. Here, associative law. A plus B plus C, A plus B plus C. Where lies the difference? Bracket. First add BC, then with A. First add AB, then with A. There lies the difference. Starting from right to left, and in that case from left to right. It is known as associative property for addition, and this is associative property for multiplication. First multiply B with C, then with A, or first multiply A with B, then with C. Both the results are equal. Both the results are equal. Then the upcoming property for real number is okay. There is identity element. Identity element according to addition as well as multiplication. Additive identity. Zero is the additive identity. Zero is the element according to addition. Zero. If we add 0 in any quantity, the result is unaltered. The result is unaltered. Zero is known as addition element, identity element with respect to addition. Zero is identity element with respect to addition. Similarly, multiplicative identity is 1. Multiplicative identity is 1 unit. A multiplied by 1 or 1 multiplied by A. The result is same. Identity under addition is 0. Identity under addition is 0. Identity under multiplication is 1. Identity with respect to multiplication is 1. Multiplicative identity is 1. Additive identity is 0. Let's see their inverses. Additive inverse. Change the symbol. To find additive inverse, change the symbol. Additive inverse of A is minus A. Additive inverse of negative B is positive B. Additive inverse of minus A over B is positive A over B. For additive inverse, just change the symbol. Just change the symbol. They are additive inverse of each other, A and minus A. Minus B and positive B, they are also additive inverse of each other. Minus A over B plus A over B, they are also additive inverses according to additive inverse of each other. Additive inverse of each other. If you add them, they all result in 0. They all result in 0. They all result in 0. Additive inverse, just change the symbol. Additive inverse, just change the symbol. What about multiplicative inverse? What about multiplicative inverse? Just make the power negative. Look at this, multiplicative inverse. Multiplicative inverse. Multiplicative inverse of A is A minus 1, or this one can be written as 1 over. Multiplicative inverse of A is A minus 1, it can be written in that fashion, or this, both are equal. Similarly, multiplicative inverse of A over B is B over A. Multiplicative inverse of A over B is B over A. A over B is B over A, or this one can also be written as A over B raised negative 1. This is known as additive inverse or multiplicative inverse. In case of multiplicative inverse, change the powers. A minus 1. Multiplicative inverse of A power minus 1 is A plus 1. A raised negative 1 can be written as 1 over A. Multiplicative inverse means reciprocal of each other. Multiplicative inverse means reciprocal of each other. In case of additive inverse, just change their symbol. Just change their symbol. Additive identity is 0. Additive identity is 0. However, multiplicative identity is 1. Multiplicative identity is 1. Okay. Distributive law, the final property. And there are also reflexive, symmetric, transitive, trichotomy law. Still they are remaining. Okay. What do you mean by distributive property? Distributive property. A times B plus C, we can multiply throughout AB. This is known as left distributive law, or simply distributive law. Left distributive law over addition. Over addition. We have multiplied something from the left hand side, and here middle symbol is addition. This left distributive property over addition. Left distributive property over addition, or simply you can say that distributive property of multiplication. Distributive property of multiplication. Similarly, if A has been placed from the right, B plus C times A is equal to BA plus C. It is known as a right distributive property, or simply distributive property. Right distributive property over addition. Right distributive property over addition. Over addition. Distributive property. We have done with additive inverse, additive identity. Yes. Moving towards two elegant questions of matrices. For what value of K the given matrix is singular? How to find transpose? In addition, I can share with you how to find inverse. Inverse means multiplicative inverse. Let's see and find out. For what value of K? For what value of K the given matrix is singular? Singular. Question hasn't been mentioned here. Singular. Now it's good. For singular, the determinant must be 0. 2K, 4, 6, determinant is equal to 0. How to expand the determinant? For singular, for what value of K? The given matrix is singular. Singular. Multiply. 2, 6, 12 minus a formula 4K, 4 times K, 4K is equal to 0. Solve for K. 12 is equal to 4K. Dividing with 4 to get value of K. 3 times 3 is equal to K. So value of K is 3. Value of K is 3. If value of K is 3, then it is a singular matrix and it has no inverse. If value of K is 3, it is singular matrix and it has no inverse. Let's verify. Insert, plug in 3 instead of K. 2, 3, 4, 6. Multiply them first in that fashion, then in that fashion. 2 times 6, 12. Minus belongs to formula 4 times 3, 12. It's equal to 0. Singular. For what value of K the given matrix is singular? Value of K is 3. Singular matrix means having no inverse. Inverse is not possible in that, in case of singular. Next question is, if we have given a matrix, we are asked to find its transpose rather than transport. Transpose. A is A, B, C, D. Just transpose. A, B, C, D. Transpose. Transpose means convert rows to columns or columns to rows. First row is AB, write in first column. Second row is CD, write in second column. That is our A transpose. That is our A transpose. That is our A transpose. Convert rows to column. First row, I have written first column. Second row, I have written second column. These are rows, row 1, row 2, and these are columns, C1, C2. Convert rows to column. Convert rows to column. And there is another elegant property. A transpose again transpose, it's equal to actual matrix. A transpose again transpose, same A matrix. That's it. Let's see and verify. This is our A transpose. Take there again transpose, AC BD transpose. Transpose means convert rows to column. AC is the first row, write in first column. BD is the second row, write in second column. Look at this. This is the original matrix. This is the original matrix. This is the way to find A transpose. Convert rows to column. Convert rows to column. A transpose again transpose. We are going to get same original matrix. Same original matrix. Here I can share with you how to find inverse of 2 by 2 matrix. Inverse of 2 by 2 matrix. Inverse of 2 by 2 matrix is given by, if A is equal to same, A, B, C, D. A inverse is given by adjoint A divided with the determinant A. Determinant A. How to find adjoint? Let's see and find out. Change the position of these two elements, DA. Change the symbol of these two elements, symbol. Position. First change position of A and D, then symbol of B and C, minus B minus. This is our adjoint. This is our adjoint. How to find determinant? We are familiar. Determinant is given by A, B, C, D. Means A times D minus BC. A times D minus BC. A times D minus BC. Divide with this. AD minus BC. This is our A inverse. This is our A inverse. Change the position of A and D. Change the symbol of remaining BC. It is our adjoint. It is our adjoint. Divide with the determinant. How to find determinant? We are familiar. A, B, C, D. A times D minus B times C. Divide with that one. It is our A inverse. It is our A inverse. Finally, we have three properties. What do you mean by reflexive? Property of equality of numbers, real numbers. Reflexive, symmetric, transitive. Reflexive, symmetric, transitive. Reflexive. Reflexive property. Reflexive means itself. Itself. Reflexive property of equality. Every number is equal to itself. Y with Y, Y is equal to Y, Z is equal to Z, and so on. This property is known as reflexive. Reflexive means itself. X is equal to X, Y is equal to Y, Z is equal to Z. Each real number is equal to itself. This property known as reflexive. Symmetric property. Symmetric property states that if X is equal to Y, this implies that Y is also equal to X. If X is equal to Y, then Y is equal to X. Their converse is also true. X is equal to Y, then Y is equal to X. Symmetric property. Symmetric property. The third one is transitive property. Transitive property. Transitive property. If X equal to Y, mathematical and Y is equal to Z. This implies that X is also equal to Z. X is also equal to Z. If X is equal to Y and Y is equal to Z, instead of Y, instead of Z, one can switch over X. X is equal to Y and Y is equal to Z. This implies that X and Z are also equal. X or Z are also equal. It is known as transitive property. It is known as transitive property. Let me share with you trichotomy law. Trichotomy property of inequality. It states that for any two real numbers, for any two real numbers, any one of the following is true. Any one of the following is true. Number one, might be they are equal. Second possibility, x is greater than y. Third possibility, x is less than y. X is less than y. From these three possibilities, any one is true for the any two real numbers. From these three properties, x is equal to y, x is greater than y, or x is less than y. Any one and only one true. Only one and only one true. Either equal or x is greater, x is less than. This property is known as trichotomy law, and it is valid for all real numbers. All real numbers. Any one possibility is true, and total three possibilities are there. There is no fourth possibility. If possible, share with me. Either they are equal, x is greater than y, or x is less than y. These are the three properties, and this law is known as trichotomy property of real numbers. Trichotomy property of real numbers. It is property of inequality. It is property of inequality. That is my final effort for your final hours of test. I have done my best to accommodate you. It's all by itself. Next.